Let's talk about solving quadratic inequalities. There are 3 steps to solving these inequalities. The first step is to solve the associated equation. In our case, this means you need to solve the quadratic equation of ax squared plus bx plus c is equal to 0. We have covered many ways to solving quadratic equations, such as using factoring along with the zero product property, the square root property, completing the square, and the quadratic formula. After you find the zeros of the function from step 1, step 2 will be to plot these values on the x-axis or number line to identify possible interval solutions. Step 3 will be to determine which of the possible intervals are part of the solution. We can do this by testing values from each interval into the original inequality to see if it makes the statement true. Or we can use our logic from the previous page. Let's use these steps in the following example. Example 1. Solve the quadratic inequality of x squared minus x minus 12 is less than 0. Step 1 is to solve the associated equation of x squared minus x minus 12 is equal to 0. Try solving this one by factoring. We find that the equation can be written in factored form of in parentheses x minus 4 times the parentheses of x plus 3, and that equals to 0. Setting each factor equal to 0, we can solve for x in each situation. Our solution set for the quadratic equation is -3 and 4. For step 2, we place the solutions we found above on the number line and state the intervals created. Here we find that the number line has 3 intervals, which are from -infinity to -3, -3 to 4, and from 4 to infinity. Notice that all these intervals have parentheses, as the inequality we are solving does not have an equal to. For step 3, we need to determine which of these intervals are part of the solution. Let's use our knowledge of graphing quadratic functions to determine which intervals are part of the solution. From x squared minus x minus 12, we know that the parabola opens upward. So I'm going to draw a parabola going through -3 and 4 on my number line. Now let's answer the inequality. For what values of x is the parabola less than or below the x-axis? From my sketch, we see that this portion is below the number line, so the solution set is the interval of -3 to 4. Another way is that we can test which interval is part of the solution is to test the x value from each interval into the original inequality to see which will produce true statements. So for the interval of -3 and 4, let's test x is equal to 0 into the original inequality. So we're going to have 0 squared minus 0 minus 12, and is that less than 0? And this simplifies to -12 is less than 0, which is a true statement. So the interval of -3 and 4 is our solution. If we would have tested the other intervals, we would have found false statements, and they are not part of the solution. Now let's try one more example on the next page. Example 2. Solve 2x squared is greater than or equal to -5x plus 12. First, we need to place this inequality in standard form by adding 5x to both sides and by subtracting 12 to both sides of the inequality. This will give us 2x squared plus 5x minus 12 is greater than or equal to 0. Step 1 for solving quadratic inequalities is to solve the associated equation. This means we need to solve 2x squared plus 5x minus 12 is equal to 0. We will solve this by factoring, so let's factor 2x squared plus 5x minus 12 into the parentheses of x plus 4 and the parentheses of 2x minus 3. And this is equal to 0. Using the zero product property, we can conclude that x plus 4 can equal to 0 and 2x minus 3 can equal to 0. Solving these equations, we find that x is equal to the solution set of -4 and 3/2. For step 2, we need to create a number line or x-axis and graph our solutions found in step 1 on it. This will create the intervals of -infinity to -4, -4 to 3/2, and 3/2 to infinity. Note that these intervals are including the values of -4 and 3/2, since the original inequality states that the values can be greater than or equal to. For step 3, let us imagine the parabola going through our x values of -4 and 3/2, so we can determine when it is greater than 0 or above the x-axis. From the inequality of 2x squared plus 5x minus 12 is greater than or equal to 0, we can see that the graph will open upward, since the coefficient of x squared is a positive 2. From the graph, we see that there are two portions of the graph that are above the x-axis. Once during the interval of -infinity to -4, and again during the interval of 3/2 to positive infinity. Let's test the interval of -4 and 3/2, and choosing a number that is in that interval. A good test value in this interval would be the number 0. So let's let x equal to 0 and evaluate our inequality of 2x squared plus 5x minus 12 is greater than or equal to 0. To see that we get 2, and in parentheses we're going to put 0 squared plus 5 times 0 minus 12, and we want to see if it's greater than or equal to 0. When we simplify this, we get -12 is greater than or equal to 0, which is a false statement, since -12 is less than 0. Since the middle interval is false, we can conclude that testing the outside intervals will result in a true statement, making them the solution set of our inequality. Finally, let's state the solution as the interval of -infinity to -4 inclusive, union including the 3/2 to positive infinity. And this concludes this video.